All right, so today's lesson is about solving rational equations. And I know if you actually read the objective here, it says to solve rational inequalities. We'll work on inequalities next class, but before we can get done with solving inequalities, we have to know how to solve a rational equation. So I know that the objective doesn't really match, but we're getting there. It just takes a couple days. Notice that rational equations are equations that can be written in the form that the function r of x is some function divided by another function where there is at least a variable in the denominator. So it can't just be like a constant number, it has to actually be some other sort of function. What's interesting about these, and we should kind of recognize this because the methods that we use to solve rational equations can cause us to get what are called extraneous solutions, which are solutions that are not really solutions to the equation. So we're going to get them when we do like x equals some number, but we have to check each of them to decide if they're actually a solution, if they're in our extraneous solution set, which means we just have to check our restrictions. And the restrictions make sense because if you remember back to when we did domain, the denominator cannot equal 0. And that's going to find us all of our extraneous solutions or all of the numbers that cannot be solutions because it would literally like make it equal to 0, which we can't have. Okay, so the steps are as follows. We're going to do a lot of annotating what I did in each step just because it looks like magic and I promise it is not. Very first thing we're going to do is always factor if needed. This problem for the first one doesn't need to have any of its denominators factored, so we can kind of skip that step. But we're going to list out all of our restrictions. So here's going to be my little bubble of restrictions, and anything that's a denominator, I'm going to say that that denominator cannot equal 0. So there's my restriction for this problem. If I got that x is equal to 0, then I'd have to say, nope, that is a restriction. So basically to start solving these, we need to get rid of the denominators. So what I'm going to do is I'm going to multiply this entire equation by a scalar x. And I'm not going to show this step out loud. Out loud doesn't make sense, but out loud all the time. But basically what I'm doing is I'm taking the first term and I'm multiplying it by that x. I'm taking the second term and I'm going to multiply it by that x, like literally just distributing this x, and then I have 14 divided by x times x. So if we do this multiplication, we're going to end up with x squared plus 5x equal to 14, because this numerator denominator is going to cancel out. Easy peasy. Now, if I know still my end goal is to solve, hopefully you think, okay, well, solving means I need to set these polynomials equal to 0, and then either factor or use synthetic division. It really won't be anything other than factoring or maybe the quadratic formula. But we're going to quick factor this polynomial, this quadratic, and then use the zero product property to say that x is equal to -7 and x is equal to 2. Those are the two solutions that I get. The very last thing you have to do is just simply make sure that neither of these two right here, these two that we just got, are in my restrictions. And since the only restriction I have is that it can't be 0, this one's fine and this one's fine. We're good. But let's write down in words what I did so that you can kind of see these steps and then maybe do them on your own. So number 1, I found the restrictions. That's the denominators, any denominator equal to 0. The next thing I did was I multiplied by the denominator. Okay, that's the next 2 steps. I then subtracted 14 so that I could set it equal to 0. And then I solved using factoring and the zero product property. So really, once you get it down to this step right here, it should be kind of familiar because we have solved these quadratics for a long time. We even solved harder polynomials like the degree 4 and degree 3, but these are going to be mostly degree 2 polynomials, so we can factor and solve. Let's look at the next example. Okay, this one's a little bit more complicated, so we actually have to add in a step that we didn't do on the next one. We need to factor all of these denominators just to make sure that we can find a common denominator. So we have 3x plus 5 over x plus 5 plus 1 over x minus 2 equal to 7 over, and then we factor that quadratic, which would actually factor to x plus 5, x minus 2. Once I've factored, I can kind of see all the things, all the factors that are in my denominators, so I can add my restrictions. Due to the first denominator, x plus 5, we know that x cannot equal negative 5. Due to the second denominator, we know that x cannot equal 2. And if you look at the third denominator, it still has x plus 5, x minus 2, which would give me the same restrictions, so like that's all I need. These are my restrictions. So to start off solving this, I need to multiply all of this by a common denominator, and probably the largest denominator, because that largest denominator, especially since these all kind of, ended up being the same factors, is going to be x plus 5 times x minus 2. Now again, I won't always show this step, but while we're learning, I'll show you this step. So we have 3 times x plus 5 times x plus 5, x minus 2. And then 1 over x minus 2. I'm clicking all sorts of wrong buttons here. Sorry. And I'm going to multiply all of that times x plus 5, x minus 2, equal to 7 over x plus 5, x minus 2, times x plus 5, x minus 2. Okay. Now, again, that's a whole lot, and once we get good at this, we won't need to be showing this step out loud on paper. We'll be able to do that in our head. But for right now, since we're learning, it's going to help you realize that these denominators are all going to cancel something out. Sometimes all of it, sometimes 1 or 2. And I definitely forgot my x here, but here we go. So now what we have left is 3x times x minus 2 plus 1 times x plus 5 equal to 7. Distribute, this is 3x squared minus 6x plus 1x plus 5 equal to 7. I'm going to combine like terms and move that 7 over at the same time because we can handle doing 2 steps at once. This is minus 5x minus 2 equal to 0. And again, because it said equal to 0 and that's what I want, I can factor this. So I set up my guess and check method. And we know the factors of 2 are 2 and 1. And so if we try the methods of guess and check, we get this as the factors, which means that my solutions are negative 1/3 and positive 2. Now, before you just box it and go, we always have to look back at our restrictions from the beginning. Notice that our restrictions say x cannot equal to 2. So actually that one is an extraneous solution. What I want you to do when you're telling me about this is go ahead and leave, don't erase it, don't completely mark it out where I can't see it. Either point at it and say it's an extraneous solution, or mark it out kind of the way I did where I can see that you found 2 and then know that it's extraneous. So this one actually only has one solution at negative 1/3. And the other solution is extraneous or isn't actually a solution because it would make that denominator 0. But before we move on, let's go back and label what each step was. So the first thing I did, I know it's kind of off screen, is I found my restrictions from my step 0 here of my factored. So that was factor the denominators if necessary. Step 1, true first step, is to look at my restrictions. Step 3, this one right here, we multiplied by the largest denominator. And it's going to cancel out all of our denominators because we have common denominators in the top and bottom. So then all we have to do is distribute. Then we set it equal to 0. And then we solve, again, by factoring, and then the 0 product property. Then the very last thing you have to do is check for extraneous solutions, which you just have to look back up at what you started with as your restrictions, because that would make potentially one of your answers be an extraneous solution. Okay, so that problem was a little bit wild because there was a lot of math going on here, but I'm going to start simplifying it The step that's in blue here, I'm going to kind of stop showing that because we can see this in our head, and so we don't need to write it down because it's just a really long step that we can do in our head. So again, the next two examples, I'm going to be skipping that step, and if you need to show it, you can. But let's also back off and go back to like an easier example here. The first thing I'll need to do always is if there is something to factor in your denominator, go ahead and factor it. There is nothing in this one I'm going to need to factor, so I start off by looking at my restrictions. And the restrictions, again, are just the denominators cannot equal 0. So we know that x minus 4 cannot equal 0, which means we know that x cannot equal 4. And that's my only restriction for this one. Oh, my phone's ringing. So we're going to start off this problem, since we've already found the restrictions, by just multiplying it by its denominator. Which means that, and again, I'm skipping the step where I'm showing you the distribution. This would be x squared minus 4x plus 1, those denominators cancel, equal to 0 times x minus 4, which is 0. So I've done the distribution and simplification already. If we tried to factor this, because it's already set equal to 0, we'd have x, and then we'd try to find a factor of 1 that would somehow get us to -4, and hopefully your brain's already like, yeah, that's not going to factor. And when they don't factor, you have two choices. You can either complete the square or do the quadratic formula. And I recommend, just because the quadratic formula is maybe something that you need to memorize for me, that we practice the quadratic formula today. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And if we plug in our numbers for that, -b is 4 plus or minus the square root of -4 squared minus 4 times 1 all over 2 times 1. Then we just start simplifying. -4 squared is 16 minus 4 over 2. I extended this for too long. And then 16 minus 4, that's going to be plus or minus 12 over 2. And if I do I'll show you a little one of these guys, what are these called? Factor trees. We have a partner of 2, so those 2's will be able to come out of the square root, and that square root of 3 stays there, over 2, which means I can reduce this down to 2 plus or minus the square root of 3. Those are my two solutions. Are either of them in my restriction? Nope, they're both good to go because neither of them are equal to 4. So there's our two solutions for this rational equation. Going back over the steps, because I think that's helpful, especially on just this front side of the notes. To get this first line, we multiplied by the denominator. And then we realized that to solve it, we're going to actually need the quadratic formula because it doesn't factor. So we can't factor and use the zero product property. We're going to need to use the quadratic formula. And the very last step is we checked versus our restrictions, which is fine. We're good. Last problem we're going to do together before you have the back to practice. Again, we have a more complicated example first. The very, very first thing before we even find our restrictions is we're going to go ahead and factor all of these numbers or these denominators so that we can see what our common denominators, what our common things down here in the denominator are. And so if we factor just that center term, the 6 over x squared plus 2x, that you can GCF out an x, and so it's x times x plus 2, which means that my restrictions are that x cannot equal -2 from the first, from this guy right here, tells me that x cannot equal -2. And then from the next one, I know that x cannot equal 0, but then also that x cannot equal -2, but I've already talked about that. And then the third one, x cannot equal 0 again. So awesome, I already have those things in my restrictions. I'm good to go. So I'm going to multiply this entire thing times the biggest denominator, times the common denominator, if you will. Which means that I'm going to have 3 over x plus 2 times x plus 2. The x plus 2 is going to cancel. I'm just have 3 times x. The 6's denominator is both of the things that I have going on here, so it's just going to multiply out to 6. And then the 3 minus x is going to multiply by x plus 2 only, because the x in the numerator that I'm multiplying by and that x in the denominator will cancel each other out. At this point, we need to start simplifying. So we're actually going to have to FOIL or double distribute the right-hand side. 3 times x is 3x, 3 times 2 is 6, negative x times x is negative x squared, and negative x times 2 is minus 2x. I'm just going to simplify because we got a whole lot of things going on here. This is negative x squared plus x plus 6. But I need to set this equation equal to 0, so I'm going to move all of the right-hand side to the left-hand side. Using inverse operations, we'd have x squared plus 2x plus 0, because the 6's are going to cancel, equal to 0. Since it's set equal to 0, I can factor and then solve. These have a GCF of x, so if I factor out that x again, I can know that through the zero product property, x is equal to 0 and x is equal to negative 2. And now I'm almost done because I need to also check these solutions versus my restrictions. And if you notice, both of these numbers are extraneous solutions. Both of them this time. And if that's the case, and both solutions are actually extraneous, this rational equation has no solution. There's no value of x that I can plug in there that would give me a true statement. It has no real solution, no solutions. So that's totally possible. Let's walk back through the steps one more time because I know I've probably lost some of you. Number 1, I factored. Okay, I factored the denominator. Then I checked for my restrictions. Then I multiplied by the common denominator. And this is, after that step, it kind of turns into the problems are a little bit different. Okay, we haven't at this point had to FOIL the right-hand side, but that's what I had to do here to start simplifying. This next step, all I did was simplify the right-hand side. And then I used inverse operations to set it equal to 0. And then I solved by finding the GCF or factoring and the zero product property. And then the very last thing is I just check those extraneous solutions from my restrictions to see what I can and cannot use. So what's going to happen on the back here is I'm actually not going to work out all of these problems. I'm just going to show you my work. And so you go step by step, pausing the video and trying the problem before you go look. Like, honestly try, because this is a good time to ask questions. So again, pause the video now, flip your notes over and try number 1, then press continue again so you can see the work. And after number 1, pause, try number 2, you can see how this works. Here we go. So here's what number 1, we should have gotten our solutions to be 3 and 1. If you want to pause this video and see, take your time to look through these steps, maybe what I did that you didn't, all that sort of stuff, that would be really good. But go ahead and pause the video now. And then go ahead and try number 2. I'm going to scoot over to number 2 in a second, so pause the video. Here's number 2. Again, pause it real fast, look at my work versus yours, see where you have some misconceptions and how I can help. Pause the video again, we're going to do number 3. So again, try number 3 first. And here's the work for number 3. Pause the video, check out what I did, see what you should do. And last but not least, number 4, pause the video, try number 4. Here's my work for number 4. All right, so solving rational equations is going to lead us to solving rational inequalities, which is what we'll be doing next time. So make sure you understand how to solve these rational inequalities, especially the restrictions aspect of it, and then this multiplying times the denominator. Cool. After this, you can get started on your homework. It's again just a bunch of practice problems. Ask questions if you have them, and you'll have a great day.